Hi, my name is Zach. I'm with Imagen Energy, and I'd like to share with you our SCALEUP project, which is a compact, high-power drive for PM synchronous machines. Before getting into our development work, I'd like to introduce you to Imagen. Imagen was founded in 2015 by an experienced technical and management team, and briefly put, our main focus is power conversion. And we seek to do this in the most efficient way possible. This means developing more efficient circuit topologies, more efficient control strategies, and using fundamentally higher performing materials. We've been awarded grants from several federal and state agencies, not the least of which is the Department of Energy. And so a lot of our designs share architectural DNA, but you wouldn't know it based on the application alone. For example, some of the projects we have underway right now are an EV charging station, battery management system, as well as the motor drive we'll talk about here. Imagen has developed a motor drive system under the ARPA-E circuits program. The design centered on new wide bandgap devices made from silicon carbide. These new switches enable us to not only deliver 500 kilowatts at a 2 kilohertz fundamental frequency, but we were able to do it inside of a 52-liter enclosure. Below in the table, you'll find target specifications for our prototype. The ARPA-E project eventually got a name of its own. We started calling it IM1500. I'd like to discuss some of its most compelling attributes. Earlier, we touched on power density, and just to give you a size comparison between our project and existing solutions on the market today, the diagram at the left shows two leading companies' solutions compared against IM1500. ARPA-E defined power density targets both by weight and by volume, and we're really happy with our power density numbers, either way you slice it. IM1500 is liquid cooled. It runs using a multi-level switching topology that in the inverter allows us to more closely approximate a sine wave, which ultimately reduces stress on the motor. The efficiency at worst case loading was still 96.5%. Imagen pushes boundaries on operating voltage and frequencies in their motor drives. And the industrial applications are fairly broad, anywhere from aerospace to oil and gas, or a current project that we have in the pipeline is motor drive for a wastewater treatment facility. These systems were developed and built in the 1980s, and after 30 to 40 years of service, they're absolutely ready for an overhaul. And there's many efficiency gains to be had. So taking a look at the architecture, we have a transformer driving two IM1500, which ultimately drives a 1 megawatt 6-phase motor. Because we're able to operate at a much higher voltage than the current competitor, we're able to drive what in their system is a 12-phase motor with only 6 phases. Looking at the efficiency chart at the bottom, you can see that the competitor's peak efficiency tops out at 96%, where our efficiency characteristic is hovering right around 99%. Here's the vision of our scale-up team. We've developed a very energy-dense and high-efficiency power electronic drive system. And we have an end customer, APG Neros. They develop and install high-speed blowers for water treatment systems. We've sourced EMC Motor as a motor service and manufacturer. And we've also partnered with UWM for aid in simulation and modeling in support of our design. And finally, the reason that we're all here. Imagen is looking for partners. We're looking to pair up with a motor designer interested in developing PM synchronous machines that operate anywhere between half a meg to 1.5 megawatts and spin anywhere from 7,000 to 15,000 RPM. It's because of our high power density and compact design, our drives would be really beneficial to a wide range of applications where wastewater treatment is maybe a beachhead market. One could also imagine applications in transportation, manufacturing, aerospace, renewable energy, energy storage. The list goes on. So we're very excited about commercialization opportunities and strategic partnerships, not necessarily bound to any one of those buckets in particular. Thank you for your time.